more helium to
Oh yeah, it kind of jumps and then it's like, find how,
to find how many grams of helium there are in 2 moles of helium multiplied by the molten mass.
Where?
Right after figure 3.
okay. So, if we're given 2 moles of helium, we have to multiply that by a number of grams of helium per mole of helium, which equals 8 grams. How do they know that helium is 4 grams per mole?
Science. Oh, periodic table.
Science. Okay. If that were lithium, if we had 2 moles of lithium, what's our conversion?
Would it be 6.941 times?
Grams of lithium per
2?
mole of lithium. Okay. And so that's where this little table comes in. So this chart, if we have two moles of something, if we have 2 moles of helium, how do we convert over to grams? We multiply by the atomic mass. Okay. Is that what we do? 2 times 4 is 8? Oh. Okay. So that works. Okay. All right. Let's look at our lab. We had copper sulfate and water. Let's look at it just in terms of this. Like, if we had, I think, did we use mean, median, or mode for our?
I think we did mode.
Median or mode?
I think we did
Mode 1.7? Okay. So we had 1.7 grams of copper copper sulfate and per 1 gram of water. All right. Well, our conversion thing was helium. So 1 atom. Do you think that we can apply Avogadro's numbers to molecules just like atoms? Yes. Right? Because all of the masses are relative. Right? They're all related. So, how many grams is 1 mole of copper?
Grams is 1 mole.
63.
0.546.
Okay. And how many pieces is that?
6.
How many grams is 1 mole of sulfur?
32.061.
Okay. And this is grams per mole. Grams per mole. Okay. How many grams is 1 mole of oxygen?
9994.
Grams per mole. How many oxygens do I have? 4. So times 4, what do I get? Well, who's got? Calculate. Who's calculating? Who's calculating?
Me.
Asher's calculating.
63.9976.
Grams per mole. Okay. These are all the same unit. Is it legal for me to add all those together? Would I be breaking a math law?
No.
No. So I can. They're all the same unit. I can add them all together. But let's take this one out. So let's just add that, and I bet we get like something like 159. 159, 609.
What?
So what does 159.609 grams per mole represent?
The weight,
Of,
all of that combined.
so if I had 6.02 times 10 to the 23rd pieces of copper sulfate, what would the mass of that be?
Your answer to the equation.
159.609. Okay. Grams per mole. I mean, it's heavy because it's 4, 5, 6 things. All right. What would the mass of, if I gave you 6.02 times 10 to the 23rd pieces of water, what would that weigh? Well, I have 2 hydrogens and 1 oxygen. So 1.00794 twice. And then 15.9994. That's, we're gonna just call it 18.01. So copper sulfate is 159.609 grams per mole, and water is 18.01 grams. Okay. Are we okay with how we came up with that? We just applied this to more than one atom. It's the same idea. Okay.
Squeeze.
If I'm given 2 moles of the thing, I multiply it by the conversion to get the grams. Well, what happens if I'm given grams of a thing?
Then you divide it by the moles.
Then I divide it by the moles, right? I just reverse my conversion. So
Yeah.
if I'm given 1.7 grams of copper sulfate,
Divided by
the idea is, okay, I have this mass. How many is that? I divide by 159.609 grams per mole, and I get what?
You get 0.0106.
0.0106?
Well, there's more numbers after that.
We don't need that many. Probably 2, really 2 is all we need. So really,
So it's 100.
if I rounded this, it'd be 0.011. So, okay, yeah, it's moles, right? So that number is telling me the amount of substance that I have. Right, so it's not don't think about it as mass really, but it's the amount that I have, how many I have. Okay. Is it okay that it's a fraction?
Yeah.
Yeah, it's okay that it's a fraction. Okay. Because it's relative to its mass. Alright, let's do water. I have 1 gram of water, and it's 18.01 grams per mole. How many is that?
$18.01, 0.0555.
0.05?
Yeah.
Moles. Okay. Alright. So, how do we think about this now? We have, how much copper sulfate do we have? No. How many?
That many.
How many do I have? This is how many I have.
Yeah.
How many water do I have?
More.
I have more.
More.
I have more pieces of water.
That's why it's so blue.
That's why it's-
Is that when you mass nitrogen and
we need to think about that. I don't want to answer that before I think about it, because I got to think about it first. Okay, so, and I want you to think about this, because we looked at this before. How much oxygen do I have on this side?
1.
I just have one oxygen. How many oxygen do I have over here?
1.7.
So technically, this should be like 4 times heavier, at least, right? But it's not. Why?
There's more.
Because they don't have the same number of pieces.
Yeah.
So if you multiply the number that we got by the Avogadro's number, that tells you how many.
Right, then that would, so if we do this, so if we have, so now we
So
have
there's
moles.
technically like 6.6242 times 10 to the 21st pieces of copper sulfate.
There you go, right? So then if we wanted to find out exactly how many pieces, yes, so we multiply it by that number. Okay? And then we do the same thing for here, and we would get a different number. That's how many pieces we have, okay? But, how many relatively? Well, how do we find out our ratio? Like exactly how many more? What do we have to do?
Hold on, I'm working on
Do we divide by the bigger one or the smaller one? The smaller one. What do we get there?
Oh, there's like 4.5.
4.54?
The 5 4.
That is funny.
Oh, so it's 54, 54?
No, it's 40.
Okay, well now we need to, so now we have a ratio. This tells us now we have one, what does this tell us?
1 copper sulfate
We have one piece of copper sulfate per
per 4.5.
4.54 pieces. Ooh, now, I want to use the word, can I have 4.5 pieces of water? No, because I cannot have a half a piece of water.
Up or down?
Can I have a half a mole of water? Yes, I could, which would be half of these. But I cannot have a half a piece of water. So, what do I have to do to find 4.5? Well, we did. It was this many moles.
That's
Do I want to say it's
3.0.
one? Do I want to say it's 4 pieces or 5 pieces? I can't have a half a piece.
It's 3.011 times 10 to the 20th power.
Should I say 4 or should I say 5? Probably 5 because it's over half.
Yeah.
So we're gonna say that. We're gonna say 5. Now, is it okay to round it and say that? Yeah, because we have lots of different results that give us lots of different ratios. So we have a lot of information. So for us to say we're gonna round it to 5, that's okay. So this compound that we were working with in the lab, for every piece of copper sulfate, there's 5 pieces of water. That's our answer.
Math is so hard.
That's our answer. So we would write it this way. So we have copper sulfate with 5 water. And that's how we write that. And then when we dried it out, we had copper sulfate. So this was blue.
It's like a chemical equation.
And then when we dried it out, water was separate. But how much water was there?
5.
5 of them. And so this is, and this should kind of make sense because we knew that oxygen was 4 to 1 by mass. So the fact that we need 5 water to be as much as that Yep. To
All
death.
that for that.
All that for that.
That's BS.
You wanna know what the right answer is?
Yes.
Please.
Is it not flying through?
You chose wisely. So we picked the mode, which was 1.7, and really 1.76. We probably should have done it more accurate. The median was 1.5. So now I want you to think about this. If we used 1.5 grams here instead of 1.7, what would that have done?
Change it.
We would have changed it. Think about that. Would this ratio be, would we have rounded to 4, or would we have rounded maybe to 6? Let's think about it. Okay. What did we do to 1.5?
Division.
Rounding it up?
We divided it first, okay? So if we have 1.5 here, is it gonna be 0.0, is it gonna be bigger than 0.01 or smaller than 0.01?
Bigger.
We have a bigger number on top.
It's weird when you like divide decimals. It's kind of like multiplication. Oh. Bigger.
What'd you get?
9,000.
So 0.009?
I told you. Bigger.
So a bigger number on top, you get a smaller number as a result.
Smaller.
Okay. All right. Now, so then now we're dividing by a smaller number.
Now it's bigger.
That gets bigger. So now we're either going to be 5 or over 5, something like that. So when you do that, 0.05 divided by 0.009
It's 55.5.
5.54.
It's
0.05 divided by 0.009.
hold on, this is
Sorry,
it's 5.55.
Oh, hey. So by using the median, we would have got 5.55, which we would have rounded to 6. Why did we pick the mode?
Because that's the most accurate one.
Why did we say it was the most accurate?
Because of all the answer.
Because if someone's getting the same answer twice or like multiple times, then it must be the most accurate.
Someone's getting the answer twice.
Really, she got the
And I
identical
think it's like
divide.
0 is the same.
Yeah, so 1.76, there was either like 2 or 3 that they both got that. So that's why we picked 1.6. Okay. All right. How do you feel? Josie's about ready to crash out.
In fact, I was like, I don't understand this.
How many of you like Josie? Like, I don't understand this.
They're really confused.
Mine's iffy.
This makes more sense in my actual math class.
Yeah. Well,
Yeah.
some of us explores in that.
Okay, let's back up. Let's back up. Because this is just day 1 of like many days. Okay.
Oh, no.
Do you feel comfortable? Like, okay, I understand the maths of the math.
Yeah.
Where do I? If I don't understand it, where do I go to find it?
Periodic table.
Right? Do I understand why hydrogen is heavier, or do I understand why helium is heavier than hydrogen?
Yeah. Because it has bonds and neutrons.
Perfect. Do I get that? So then, do I understand that if I have the same number of pieces, now if I talk about pieces, helium is going to be heavier than hydrogen.
Yeah.
And so, but if I had more pieces of hydrogen, now they could weigh the same.
Yeah.
But it's going to take more pieces.
Yeah.
Okay.
In fact.
Alright, so now then we apply that to a problem, right? So now,
I think I figured it out. like the steps to do it, but there's just a lot of steps.
It is. I mean, we took a very like long route because we like defined all the stuff and then we're like, how do we apply this to a problem? But later it would just be like problem.
Yes.
Also, no, you're.
Thanks,
Can I get a
sir.
Band-Aid?
You'll have to go to the office. And if you ask Mrs. McCormick very nicely, she will send you with some more so that I could replenish my Band-Aid supply.
You also need tissues.
But she will have.
Where Miss Branscombe?
Oh, sorry, Mrs. Branscombe.